Okay, so let's start with the presentation today. Thank you so much for being here. Let me introduce you first myself. I'm Carlos Martinez, Director of the Training Department of SODECA. And we are today with Raul Ramos, Project Department Engineer, Smoke Control from the Project Department of SODECA. Thank you, Raul, for being here. And we are talking today about ventilation in chemical warehouse and ATEX zones. I think it's a really interesting theme and based on the knowledge of Raul in this industrial project. I think it will be so interesting. Let me remind you, we will have more or less 30 minutes of presentation. Then we will have question time. You can write down your questions in the apartment you have in the panel control, and we will share with you the presentation at the end of the same. So don't worry about taking notes. I hope you find this interesting. And Raul, when you want, the floor is yours.
Okay, thank you so much, Carlos, for presenting me. So the presentation, the learning, it's about ventilation, chemical warehouse, and ATEX zones. And I'd like to start with a summary of the content of this microlearning. So first of all, we'll talk about what is a chemical warehouse, then explain all its characteristics, then expose briefly the main international standards to follow for this purpose. Then hereafter recommend the ventilation solutions that SODECA provide in different types of chemical products to store in warehouses, in the different types of chemical products. So let's start about what is a chemical warehouse. Well, we can define it as an enclosure to store chemical products that may represent a hazard that could be either flammable, corrosive, or toxic. On the left side, you can see the pigments you know and you can see the different chemical products we have in the market. So each type of product should be treated different in terms of ventilation and maintenance of the warehouse itself, and also for the maintenance of the industrial state of the zone where it is placed. Otherwise, and this is what happens if you don't get it right, you could face a huge disaster. First of all, we have 3 examples of chemical accidents that happened in the history, and I tell you briefly what about any of them. The first one is the Bhopal disaster, what happened in the 80s in India. In this case, we had a methyl isocyanate tank that exploded and leaked a toxic cloud that killed around thousands of people, between 400, 4,000, 15,000, depending on the source. There was about 500,000 people injured, and it was a huge contamination of the environment around. The second explosion was the Ecoxe Tarragona accident, happened 4 years ago, where an ethylene oxide tank, which is an ATEX product, was bad maintained, and it resulted in an explosion that killed 3 people, injured 7, and brought about 6 million euros of economical losses for the company. And then we have also the Imperial Sugar explosion that happened in Georgia, USA, about 15, 16 years ago, where there was a dust explosion due to sugar accumulation at high temperatures. In this accident, there were about 14 people killed, 36 injured, and there were economical losses of $15 million in this case. So to take into account at European level and international level, we have different standards to follow in case for storage different chemical products and also for its ventilation. First of all, we have the health and safety guidelines provided by the British government that were accepted at European level. Then we have 3 different HSG, which are the 51, the 71, and the 176. The 51 explains it's about the storage of flammable liquids in containers at workplaces up to 1,000 liters of capacity, and explains the 5 explosion hazards associated with flammable liquids. The 71 is about chemical warehousing. It contemplates the storage of dangerous substances, regardless of the size of the facility, and it sets out control measures aimed at eliminating or reducing risks from the storage of packaged dangerous goods. And then we have the 176 that applies to above and below ground fixed bulk storage tanks with capacities more than 1,000 liters. Then we have different European norms. We have, first of all, the 60079 part 10.1. It's about classification of areas in explosive gas atmospheres with type of gas attic zones. Then we have also a 10.2, which is about dust attic zones. It's not here. And then we have the European norm 14470 part 1, about safety storage cabinets for flammable liquids. It explains how the dimension of this type of cabinets and how its ventilation should be. Now let's continue out the ventilation solutions for the different types of blocks to store in warehouses. First of all, I'll talk about the flammable ones. What's the main objectives? So the main objectives here are to avoid the generation of an attic zone, keeping the concentration of this gas or this product below the lower flammability limit. Also, we want to ease the dilution in case of an attic generation and reduce its permanence. Also, to avoid the exposure to environmental limit value, which would be harmful for both environment and people inside. Also, we want to exhaust the smoke in case there was a fire. So we move forward to what is an attic zone. Why is it important? An attic zone means which is an area where a gas or dust will be accumulated, and it can form a mixture that can cause an exothermic combustion. It would be formed by a component, normal oxygen in the air, a combustible, the gas or dust we are treating, and also an ignition source, so we need heat. And this exothermic combustion induces a fire that also can induce a forward explosion. Then here we have an image of a type of accident because of an attic generation, and also have the picture on the signal we will see in any attic zones. It's normative. This is a standard. We standardize it. Here we have the classification of different attic zones. We define from more dangerous to less dangerous concerning the explosion risk zone. So we have zones in 0, 1, and 2 for gases, and 20, 21, and 22 for dust. The definition is the same. For the zones 0, 20, tells about continuous and frequent hazard, so it's not possible to use active motors due to the spark risk. Then we have the zones 1, 21, where there is a possible hazard in normal operating conditions. And then we have zones 2 and 22, where they're not likely and more infrequent in normal operating conditions. So it induces an occasional risk. Then once we can classify the attic zones, we should declassify it by the means of ventilating that zone. So we have 3 different aspects to take into account to declassify attic zones. First of all, one of them is the rate of release. Then we have the effectiveness of the ventilation and also its availability. Concerning the rate of release, we have continuous, primary, secondary. The continuous is when the release, the leakage is frequent for long periods. The primary is when it's periodic or occasional, and the second is when it's frequent or not expected. Then about the effectiveness of ventilation, we can face a high dilution, which is the best option, where concentration of the gas decreases rapidly. Then we have the medium dilution, where the concentration is controlled below the lower flammability limit. And then we have the low dilution, which signifies that there is still a significant concentration where this leakage is still there. And at our average of ventilation, we have the good one, which is continuous. The best is the best option. The third one is that expected in normal operation, and then we have the poor one, which is neither good nor fair. And with the class of ATEX zones, and then the means to the classificated, we have this table interpreted in the norm 60079 part 10.1 that classifies the zones regarding the rate of release, the effectiveness of ventilation, and the availability of ventilation. The best option is to have a zone 2, either a zone 1, but in the mean of possible, we should be aware to not have any zone 0. So the most important part is if you have a good ventilation, a good availability of ventilation with a high dilution, you don't face any hazard inside. Then what SODECA provides? Then SODECA in this case for these ATEX zones provides anti-spark fans driven by electric motors, and we have also different motor types for regarding the product type or the type of gas or gas concentrations, the zone where the ATEX zone where it will be placed, either is 121 or 222, and we have this range of fans. It will be axial fans, centrifugal fans, wall-mounted or roof-mounted fans. Then we tell that it's important to exhaust the smoke in case of fire. So smoke control is also very important to control a fire where we have flammable products. Then why is it important? Because there will be a risk for the people inside. They can be burned or asphyxiated because of uncontrollable smoke release, and it can compromise their lives. And also, smoke uncontrolled smoke when controlled fire could induce further exposures. So the main objectives are to avoid the smoke formation and also facilitate the evacuation of people. How SODECA do it? They do it with ventilation, with exhaust fans and also air supply fans that were placed, as you see in the pictures, supply fans at the top of the plant or top of the industrial estate, and air supply fans at the bottom level to ensure that fresh air fresh and clean air will enter. At the same time, we exhaust the contaminated air. We can do it in different forms. Have a part to do in buildings with a single floor, is the picture of the left. Also with multi-level buildings, the image of the right. Also with compartmentalizing the different levels the state could have. And the solutions SODECA can provide, there are those temperature certified fans. There are fans that could resist temperatures of 300 or 400 degrees in a period of 2 hours. They could provide fresh air supply and also an exhaust of polluted air. They help to decrease the temperature of the site, and because of the entrance of the clean air and the clearance of the smoke, we will have also better visibility of the zone. Now we'll move to how to face corrosive product warehouses. The main objectives are clear. They are to avoid the steam condensation of corrosive products, also to keep separate vapors of chemical products that can react one with each other, that could form a toxic cloud that be dangerous for people inside, and also to avoid, as I said, the exposure of people to environmental limit values, not compromising their lives. With corrosive products, we have conventional fans with anti-corrosive treatment, as are the CPV models. They have an image of one of them on the right side, which whose case is made of polypropylene and also it's storing. It has a plastic finish that prevents the fan to be affected by corrosion. These kinds of ventilators are also may be vulnerable for ATIC's use. I didn't say before, but there are some temperature certified fans like the THT that can be used also, can be modulated for ATIC's uses. And then we move forward to the toxic product warehouses, whose main objectives are to avoid the exposure of people to environmental limit values, also to avoid the emission of gases or toxic products to the environment or to areas occupied by people, to not harm them. Then we can know the concentration of products that can be toxic with the toxic thresholds, which are the limit concentrations for each product in terms of particles per million, ppm. And the three main thresholds used are the AGL, the ERPG, and the TEL. The AGL, the acute exposure guideline levels, it tells about the exposure limit threshold and make different toxicity grades regarding the period of time of exposure, which range from 10 minutes to 8 hours. Then we have the level 1, where concentration of them may pose incomodity to people. For the grade 2, we have the concentration above it. We will face various effects and possibly reversible. And the grade 3, that's the concentrations above them, that could face serious effects for their life. For the ARPG, the emergency response plan guidelines, tells about the range of concentrations also in different grades in a 1 hour exposure. Then we have the level 1, that's the maximum concentration of a product. Below that can induce adverse effects temporarily. The level 2, that the maximum concentration that below that it cannot induce irreversible damages. And the level 3, there's a maximum concentration of a product. Below that cannot induce death. So we've got to take into account that above level 3 concentrations, the product will be toxic and lethal for people. And the TEL follows the same pattern as ERPG, but in this case in a period of 15 minutes of exposure. And it has 4 degrees from level 0 to level 3. And same that level 0 is a maximum concentration. Below that, there will be no hazardous effects. Level 1 is the maximum concentration. Below that, people will only know light effects. Level 2, it's maximum concentration. Below that, people will be exposed without irreversible damages. And level 3 is a maximum concentration. Below that, people will not be exposed to death. To solve this kind of problems, we have from SODECA, we can tender for this purpose conventional funds, either actual or certificate, to dilute the concentration of those toxic products released. And it's considerable for our part that we have different model products that ranges for multiple uses. So almost all these funds that I present, they can be moderated, for instance, for ATIC's uses. So if you have toxic product that could generate an ATIC zone, then we can tender a module that could be used for both cases. So to finish it off, I want to say that SODECA has a project department, to which I belong, specializing in consultation and design of this kind of projects, making personalized studies by using our different tools that facilitate it. One of those tools is QuickFun, which is our software for making calculations and selecting the best ventilation for its use. We also dispose 3D models and BIM systems for more than 5,000 fan models. You as an engineer, as a client, you can tell us your proposal for a NATEX project, for a chemical warehouse project, and then we prepare the report, including the necessary airflow, making different calculations, and also selecting the the fund that suits to your needs. So this brings me to the end of my presentation. So if you have any comments or questions, I'll be so happy to answer them. Thank you so much for your attention.
Yeah. Thank you so much, Raul. What a nice presentation. Allows me to make bottom line just for the people that are seeing this morning. As you can see, this is only an approach to this ventilation system, ventilation projects for chemical product warehouse. You can see with this presentation that we will have different risks, and all of them can be solved by using ventilation systems. So I encourage you to contact with Raul, with his team, in order to study together this kind of projects that, as you can see, we are experts in industrial ventilation. So in this time, I hope you are writing some questions for Raul. In the time, Raul, you can share the presentation with the people and make time for the people write the questions.
Sure.
So you can have you can download in a couple of minutes, and if not, if you have any questions. Yeah, that one. Mhm. We are seeing your folder, eh? Yeah.
Okay.
Yeah,
Now,
nothing
no,
to hide, eh? Nothing to hide.
no, for sure. Okay, now I'm sharing
Yeah, I can see it.
the presentation.
I think everybody can now download it. If you have any problem, you can write to Raul or to me in order to receive the presentation. You will be at least, I think, at the end of the presentation, you will have the opportunity to review the video if you want to share with your colleagues. So I hope you find it interesting. Raul, I don't know if you have any question, because you explained the thing very well. So I don't know if there are any doubts.
For my part, there is no any question for now. And if the people assistants can have any question, that tell us and I
Yeah.
answer it. No, there's no problem.
You know, Raul, people normally are shy in the middle of the public space, but probably you will have more than 2 or 3 emails in your account. So thank you so much, people, for being here again. I will remind you that we have this microlearning program until the end of the year. The next microlearning presentation will be about the radon gas, the indoor air quality. So I encourage you to register as well as this. And Raul, thank you so much for your presentation. See you soon.
You're welcome, Carlos. Thank you. Thank you to you. Thank you so much.
Bye bye. See you.
Bye. See you.